All right, I never know for sure when we've started, but it looks like we've started. It's good to be able to see you again. Wow, we've had a string of cloudy nights. But during that time, I have been able to pick up a few things here in the rig. So we'll be trying those out tonight. My name is Doug. I'm coming to you from the outskirts of Louisville, Kentucky. I had a bit of laryngitis last week. My voice is still recovering, so I'm sorry it's still a little bit wispy. Let me just see if I can bring up the stream on this little iPad here, which allows me to be able to make sure that I'm hearing audio, and so far I'm not seeing it. So what do I need to do here? Let's see. There's live. Just doesn't seem like it's there yet. I go back here again and try to find it again. Oh, there it is. Okay, now we check this audio. Oh, there it is. Okay, now we check this audio. Okay, so it looks like we have audio, and there's Stan. Good evening, Stan. And Wendy. Thanks for joining us, Wendy. This was not a previously announced observation night, so if you watch this later as a recording and say, why was I notified? We didn't send out an email about it. Number one, I didn't know if my voice would hold. But number two, I'm kind of like just getting my muscle memory back for everything again since it's been a month or so since we've had a clear night. Finally, one last little glitch is that my Windows computer went belly up, and it meant that I had to wipe the hard drive and install everything from scratch. So although a lot of my stuff was backed up, some of the configuration and all, I'm just now getting set up. So let's go ahead and get started. We've got, let's see, there's a view of the scope. It's RASA 11 out there in a roll-off roof observatory made by Pier-Tech, the Tele-station 2. It's on an adjustable height frame, an adjustable height pier, so it's just poking its head up above the edge of the roof of the observatory there. We've got a pretty clear sky there tonight. You can probably make out, can anybody make out the Big Dipper? Maybe make out the Big Dipper there. Let me go over to that screen and see if I can point. See. There we go. So here's Ursa Major. You can probably make out the Big Dipper here. And then if you follow the pointer stars, you get down here to the North Star. So here's Ursa Minor, just for orientation. This is a live view. This is through our ZWO ASI 178 monochrome camera. This kind of gives us a connection with the sky. If you continue those pointer stars through the North Star, you kind of come over here to Cassiopeia. And depending on where Cassiopeia is in the sky, sometimes it looks like a W, sometimes it looks like a throne. Maybe you can see the throne tonight, the chair. Anyway, there's a view of the sky, and let's see if we can bring you here to our screen. This is a live view through our ZWO ASI 2600 MC Pro. That camera sitting on the end of the RASA, and this gives us a little closer up view of the stars. Pretty good focus. If you like, before we get started, we can do one more focus run. Let's take this focuser off there, take that off, and let's go grab Nina. I've been really impressed with how fast Nina is in this new version. This is Nina 3.1 HF2. Let's hook up the focuser here and hook up the camera, and then go to imaging and say start autofocus. So now you can see a frame of the sky form up here on the left. So you'll be able to see, here's what Nina's seeing. Then here on the right, you can see the point at which the focuser was for the first frame. And it takes a couple of shots there and averages them together. And then it goes on to the next like 30 stops away in our motorized focuser. And takes another couple of shots. And you'll see it's really progressing quickly. Ty Kim, welcome. You're asking about the planets being aligned. I don't think we have a good view of the planets tonight with the view that you're thinking. This is Stellarium. It's a Planetarium software. And let's just look for, say, Saturn. See, it's below the horizon. Let's look for Venus, also below the horizon. Let's look for Jupiter. Okay, so there's Jupiter. Yeah, I think we would have to wait for more of the planets to rise in order to be able to see them. Let's run the sky up and see Jupiter's setting over in the west. So why don't we hold that for a second and look here in the east. And spin over to in the morning. So there's 2 a.m., 3 a.m., 4 a.m., 5 a.m. Now let's hold it there for a second. Now let's search for Saturn, still below. Six a.m., 7 a.m., Saturn, still below the horizon. There we go. Okay, so tomorrow at 8:50 on March 2nd, here's Venus, Mercury, Saturn, and of course the Sun. So honestly, it's just not quite right yet. Sorry about that. I know that the media is making a big deal about that, but another problem we have is that our RASA 11 just doesn't quite give us a big enough field of view to be able to see. Like there's the field of view of our RASA 11. So you can see it's just not big enough. Take a look at, we just can't see all these planets. It's better to go out with binoculars, I think. Get a little more out of it then. Okay, let's go back to the here and now. Okay, so there we are there. Let's go back to Nina and see how our focusing did. It's a beautiful hyperbola here. You can see it took the lowest focusing setting. Okay, so let's go back to our equipment. Let's the equipment, focuser, disconnect the focuser, disconnect the camera, close Nina. Now let's come back to, excuse me, Sharpcap, grab our camera again, and I did have a combo screen here, so you can see the telescope in the lower right, and the sky over there in the right below me. And then I'm here, and then this is the live view. All right. Hello to 3, and then I think those are those Chinese, Japanese characters? Anyway, good to have you aboard. I think maybe those are Chinese or Japanese. Please forgive me. One or the other. Anyway, good to have you aboard. Okay, so you guys are here with us. You must have just stumbled across, Larry, good to have you. You must have stumbled across the live stream because you have notification on, so thanks for that. Let's get started. The first thing let's do is go over here to our, by the way, we have a full view of AstroPlanner here. And notice the first thing it has here is the Headphone nebula, PK164 plus 31.1, kind of an obscure, rather exotic sounding name there, huh? Let's grab our scope and slew to this object. Oh, there it's starting to turn. You can see a real-time view of the scope changing its orientation. See how the weights are kicking up there on the left side. In our camera's view, the weights are on the west side. So now the scope is what you might call pier east. And it looks like it's pretty settled in there. Now, trying to think of how this works, try to get this figured out. If we come back to our combo screen, there's this new thing in our panel up here. This is our new EAA Control Panel, and it's version 0.5 beta 5. So what Pete has done here is, first of all, he said, can we show the object that we're looking at? And he lets us put in manual text, and then he also lets us put in ID, name, constellation type, magnitude. Okay, so let's try this. What happens if we click that on? Now what that has done is it puts the object text in this path here. It puts it in a text file. Looks like we don't have it named. Let's go to AstroPlanner, object title. There we go. Do you want to already exist? Did you want to? So that's the path. AstroPlanner object title object underscore title dot txt. Okay, now let's get that out of the way. Now what I think we want to do here is we want to go down here in our OBS software, and what we want to do is, let's get rid of that, and let's add what we want to try to do is show the contents of a text file. Here it is, AB text. Let's try that. Add existing, select source. Where do we tell it what text file we want to show? Add, let's see, window capture. Add text, GDI plus. Add existing. But it won't let us click that. So how do we add the contents of a file? Text free type 2. But it doesn't let us go browse for it. Okay, I'm just gonna, for a second, go out here to the web. I'm gonna say OBS, how to display the contents of a text file. Create a text source, then press to read from file. It is the text GDI. Read from file. Sets the source to read from a text file instead of the text property. Read from file property. Ah, it's supposed to have a checkbox there. Read from file. So we must not be seeing all of the contents of it. Let's try this again. Add existing. Well, properties. Properties for, oh, maybe it's at the top of the screen. That's probably GDI. Create new, I see. So let's call it title. Okay, read from file. Now we're cooking. And we're going to browse for an AstroPlanner object title.txt. Okay. Now we're going to say we want to be up at the top. So how do we let's go back to this. That's just a huge font, isn't it? So let's go back into the properties, and for the font, let's make it more like 36. Now we're getting closer, aren't we? Now that's too many characters. Let's go back up here under options and say name planetary nebula, magnitude, maximum characters, 30. Okay, now it's working. So let's make it about 70. So we go options 70. Okay. So now we have the title up there. You can always see what we're looking at, and thanks to Pete, I don't have to type all that in. Isn't that cool? So hats off to Pete. At any point, we can just hit object text, and it shows us the last object that we were seeking. Now the next thing is we want to figure out how to show the scope location. Let's go over to Stellarium and Stellarium sync.
Selected. Okay,
so there's where we are in the night sky. So you can see we're kind of a little bit left of north. Stellarium
selected.
Sync. Okay, and then let's say telescope trailing.
No telescope selected.
Choose scope. Aha. We have the I don't know if we're supposed to say this or CPWI. Let's try this. Update rate. Okay, so hopefully it'll...
Telescope connected.
There we go. Now hopefully it'll show us where the scope is pointing from now on. So thank you, Pete, for that. Okay, add to AstroPlanner. Okay, so the next thing let's do is let's go back to Sharpcap, and let's do a plate solve. Make sure we're pointed at the right part of the sky. We were off about 1/3 of a degree since it's the first. Yes, Tychem, you're right. So complex. But part of it is because we're getting this stuff installed, see? And that's one of the reasons we didn't advertise tonight, is because we were just trying to install things. This is supposed to be the Headphone Nebula. It's object number 187. It's a planetary nebula. So now let's start live stacking. So we're going to go prep for imaging only. Okay, so this is PK164, PK164 plus 31 plus 31.1. And this is the screen that shows that that's the end of our sequence. Now what's down here? I see. There we go. And then back to this. Okay. Now let's See anything that looks like a planetary nebula there? Not yet. Object 187. We're using as our book this Cosmic Challenge book by Phil Harrington, and we've been working our way through. I think there are probably 670 targets in all on this list, and we've observed 598 of them, so we have 72 yet to go. 187. PK 164 plus 31.1, and in each case he gives you a map so you can, you know, find the object in a very close way. He gives you a little summary chart, and then he gives you text, you know, about the object. So it's been an enjoyable list. There was once a mystery in Lynx. The story opened in 1790 when William Herschel discovered a small nebulous glow about 2.5 degrees northwest of 27 Lyncis. He later added it as number 830 in his list, very faint nebula, abbreviated H3830, and apparently moved on without noticing a second, fainter blur of light just to the northeast. The second object was discovered 66 years later by William Parsons, 3rd Earl of Rosse, through his 72-inch Leviathan reflector. So it's NGC 2474 and 2475. Sounds like they incorrectly labeled them NGC 2474 and 2475. 40 years later, they discovered that mistake. So NGC 2474 and 2475 are a close pair of elliptical galaxies discovered by Herschel and Parsons. So it's not a planetary nebula at all. Look for... tells where to look for them. Not sure about the magnitudes. These are the galaxies, and in any wonders, what did the first two guys discover? The answer of the mystery of the missing links. 1/2 degree further north, there we find a planetary nebula, a real planetary nebula. That today, is identified as Jones-Emerson 1. So PK 164 plus 31.1 is an unusual ring nebula. He puts it in the Monster Scope Challenge chapter, and monster scopes are typically 15-inch and larger. And we do not have a monster scope, but hopefully with EAA we'll be able to see this. Now, let's go back over here to our... Okay, now we're seeing some things, aren't we? Let's see. that. Starting to see the headphones? It's the Headphone Nebula. Man, can you believe that? It was only visible after about 5 or 6 minutes and some really, really wild stretching of the mids. You can see it's a very large planetary nebula, comparatively speaking. There is a zoom of 20%. Here's a zoom of 100%. I think this is extremely large. Let's see what amount of the night sky is this actually taking up. 6 arc minutes. It's 14th magnitude. Does look like a pair of headphones, doesn't it? A lot of these planetary nebulae have polarizing features because of the way the gravitational forces interact with the central star. And I don't know if that's the central star. It could very well be. That could be the central star. When that central star jettisons out this material, it gets collected in certain areas. You can see it's colored a lot more red there. We see a lot of grain in this picture. See how it looks very mottled? That's because we have our mids up so high to be able to see it. If we back off the mids until there's no grain, you can still make out a little bit of the headphones, can't you? Okay, so let's go here and let's say quick observation. Good. And look, it says log P164 plus 31.1. We'll say large planetary nebula with an interesting past was somehow confused with 2 galaxies, NGC 2474 and 2475. Faint 14th magnitude, but large in our RASA viewfinder, our RASA image. Okay.
Observation logged.
So as you can see over here in AstroPlanner, we now have the number 1 in this column showing that we made 1 observation there. So we're ready to move on to our next object. Now we can try to get in a rhythm. Next target. And let's just go to the next one, NGC 1924. NGC 1924, this is object 118 on the list. And it looks like it's settled. So there it's plate solved. Yes, it had a little bit of red color, Taikem, good point. It's a clear night tonight. We started seeing this night size up several days ago, but I tell you what, I was such a skeptic because so many of the clear nights had had clouded up and had resulted in us not being able to observe for so long that I was afraid to trust that we would really be able to do something. So I kind of held off. Wow, that's a beautiful night sky, isn't it? This is supposed to be a Galaxy NGC 1924. Now we can do up here under Tools, do one last little bit of plate solve only and then deep sky image annotation. And that's where this galaxy should appear, NGC 1924. So you see this pattern of 4 stars here should point down at it. Its magnitude 12.53. So let's zoom in. Boy, nothing yet there, huh? Okay, let's go read about this. This is object 118. Hein Chari, good to have you aboard. Welcome. Where are you observing from, Hein? Larry says, clear here for now, but windy. Boy, it is windy for sure. And we have windy on the stream with us, by the way. 118. NGC 1924. Wow. Doesn't look very big. You've heard about the Andromeda Galaxy and the Orion Nebula, but what about the Orion Galaxy? Probably not. Particularly intriguing was realized so close to everyone's favorite winter deep sky object, M42. It's a barred spiral discovered 1785 by William Herschel. Okay, let's go up here under Tools and plate solve only. 1924, so it should be at the end of these 4 dots. Alt D. Boy, we're just not seeing it there, are we? That's at 150%. I think that's it. Look how our stars kind of have an oblong shape. That's probably due to the wind blowing the scope around out there. All of that scope is above the roof line of the Tele-station 2, so I'm sure that the wind is definitely rocking it. Boy, let's go to Stellarium and say Stellarium
Selected.
sync. Says we're dead on. Wow, it's not even going to be very easy to distinguish from a star, is it? Let's see, where are those 4? Here they are. 1, 2, 3, 4. And that points there. To the, it's like the middle star of 3 in a row. Okay, let's go back to our one, two, three, four, with 2 stars in the middle of the first 2. Must be it there. Not very distinguishable, is it? Stu, good to have you aboard from Tauranga, New Zealand. Stu's reminding our folks, don't forget to click the like. It helps others find the stream in the algorithm. Mark, I can see it on my C-Star S50. Cool. That's the Headphone nebula you were seeing. Good to have you aboard, Hein. That. Look at this long trail of stars here. 1, 2, 3, 4, 5. If you count those two, 6, 7, 8, 9, 10, 11, 12, 13. Just a long string of stars. Then you've got pretty bright ones. 1, 2, and then Planetary Nebula would be the third one. 4. This is kind of a double, so 1, 2, 3, 4, 5. Now that's Stellarium. Now let's go back to the live view. Right here. Okay, so here's that long string of stars. And somehow it's a lot harder to detect. Let's go up here under pre-processing and see. Yeah, hot pixel removal, and we're applying a flat. Let's turn that off. There we go. So what was wrong is our display histogram up here was turned on. Now let's zoom in here. So now you can see this planetary nebula. It just has a glow, a faint glow around it, doesn't it? And that's the central star. And that star is probably in the foreground there. Not an extremely compelling thing, but definitely visible, huh? Not a lot of color there in our view. NGC 1924. Maybe this is actually not a planetary nebula, it's a galaxy. Yeah, this is one of the Orion galaxies. It's only 1.5 to 1.1 arc minute wide. It's just 1 arc minute. So it's a faint oval disk accented by stellar nucleus. Brightest outer edge and star-like central cores close mimicking the look of a planetary nebula add in the spectacular surroundings and how they add a faux 3D effect. And the beauty of this little treasure really comes through. It's a challenge that you are sure to return to time and again as you further explore its more affluent neighbor, which of course is the Orion Galaxy M42. Okay, here we go. Observation. Almost has the look of a planetary nebula. Faint glow around the core and a star-like likeness in the core itself. Only 1 arc minute wide.
Observation logged.
Very cool. All right, next target is PAL 1. Stu says 85 degrees today, beautiful day in the Bay of Plenty. 85 in Freedom Units, 30 degrees for the rest of the world. 85 Fahrenheit. Now, this time, I need to get in the habit of, when we go back to the combo screen here, I need to say object text. Look at that. Go, Pete. I forgot on the last object. It's so much easier than trying to type all that in, Pete. We have a 10-mile-an-hour wind here in Louisville today, Stu. And I think the real temperature was around 35, so with the wind it made it look like 25. Isn't that a beautiful star field? My goodness. Look at all those beautiful pinpoint pricks of light. Little pinpoints. Amazing. Okay, so what are we looking for here? Let's go down here. This is a globular cluster. Must be one of those globulars that, you know, the star field is so rich and the globular itself is fairly loose, so it doesn't really stand out, does it? Again, it's called PAL 1. And you can tell by the designation that it's not a very, like, it doesn't stand out, does it? Because if it did, it would have an NGC number, one of the NGC numbers we see so often. So we'll plate solve only, and then put on the deep sky, none. Okay, so what we do in this case is we take the object and say Sharpcap DSA.
DSA copied to clipboard.
And here we say paste custom object info. Look at that. So that way it actually places it for us into Sharpcap, even though it wasn't originally noted there. So look how compact this globular cluster is. Faded back at, a starting percentage. Not seeing a whole lot there. Right there. This is object number 181. It's in the Monster Scope Challenges. So this is from the Palomar Global Clusters list, PAL 1. The most northerly globular cluster visible to amateur telescopes, and one of the youngest. 6 billion years old, half as old as the Milky Way globulars. Palomar 1. So it's right here. Pretty loose. In fact, if you look very closely, look how there's a higher percentage right here. Right here. Let's see, 2.8 arc minutes. Arc minute wide globular cluster on a thick star field, so fairly tough to resolve at first. Live stacking brought out the details in just 4 minutes. Approximately 50 members in a tight knit blotch.
Observation logged.
Larry says, I don't see a glob there. Okay, let's take one last look here and see if we can bring it in. It's kind of, what's the best view? It's kind of there, but it sort of encompasses all of that. know if you can make it out now, Larry. There's something there. See how there's a pattern there. Okay. Next object is NGC 604. It has an altitude of 3 degrees. It's not very tall. The best time was 7:45. It just depends where it is in the sky. I think it's going to be in the horizon. But let's go check it out. Huh. I guess because it's in the horizon, it's not going to let us go there. Let's change our sight to low horizon. See if we can override that. Yeah. There we go. And this is NGC 604. Yeah, too low on the horizon.
Selected.
Yeah, you can see that's kind of our representation of where the tree line is. And we're definitely down in the trees. So that one's going to have to wait for another night. Okay, let's go to ARP 82. Ken, good to have you aboard. Welcome. Okay, looks like the scope has settled. ARP 82.
Selected.
Excuse me. Almost looking straight up. There's the meridian. We're on the west side, so it's already past the meridian. Did I not tell it to go on? Thought I did. Wonder if this was the old sequence that stopped. I think it is. Okay, now let's plate solve. Stu says, ARP-82 is an interacting pair of galaxies with a strong bridge and a long tail. NGC 2535 is the big galaxy, and NGC 2536 is its smaller companion. Okay. Looks like we had to tune up our location. Looks like all that's done. This is, again, ARP-82. ARP-82. Looks like I'm going to try to do the Messier Marathon again this year. I think I'm going to have to try it on an off night. Let's see. March 27th. Yeah, Thursday night, March 27th. And part of that's due to calendar, just my own travel schedule. And then some of it's due to when the moon will be least impactful. So if you are available, and if it does end up being clear, we hope you'll give that a try with us. Aha, see something in the middle there now. Look at that. Ooh, kind of a haunting little wisp of a galaxy with two little eyes in it, huh? ARP-82 with NGC 2535 and NGC 2536. Wow, looks ghostly. Yeah, NGC 2535 and 2536. So this is 2535. Interacting galaxy pair, NGC 2535 is being bent out of shape by NGC 2536.
Observations for 3 objects logged.
Yes, Stu says would look amazing if we stacked it for half an hour. You bet. Look at that little wisp. Looks like a little, I don't know, like some kind of little ghost character from some cartoon or something. This is 154. ARP 82, the 82nd entry in Harrington ARP's catalog of interacting galaxies. Strange pair, galactic version of Arrested Development. With his 18-inch, he really doesn't get a very clear picture. No hint of a structure. Okay, those have already been observed, these three. So that takes us down to this stack. I don't know which one to try to go to see the most of them. We'll just pick any one of them. Let's just pick NGC 2624. Stu's still looking back at the interacting galaxies. Says they're pink, blue, and green in the Spitzer picture. Nice. Okay, so back in Stellarium, we can say Stellarium
Selected.
sync, and it'll take us to the current field of view. Look, we're on the edge of the beehive. Nice, look at that title. I love that. Galaxy. ZG 7341 or NGC 2624. So there's 2624. A little spray of a galaxy there. Not very impressive galaxies, huh? Let's go read about these. Object 157. NGC 2624 is a spiral galaxy located in the constellation Cancer, 211 million light years away. Thanks to 2624 is object 157. It's in the Monster Scope Challenges. Twenty-six, 24, 26, 25. Tiny galaxies in Cancer, 211 million light years away, thanks to
Observations for 2 objects logged.
Okay, let's go to NGC 2637. Let's just make sure it's not
DSA copied to clipboard.
visible here. And it's not. Excuse me. $26.37. Boy, such a beautiful star field. Okay. It's quite a busy star field, isn't it? $26.37. It's right up there at the top. $26.43. $26.43. It's not in this frame. $26.47. Not in this frame. I don't think. No. There we go. Stu says you're looking for something 0.5 arc minutes across with a magnitude of 15. Yikes, it's going to be hard, isn't it? No wonder it's in the monster scope section. So here's 2643. Right there in the center. Aha, there it is. Right there. Boy, it's just, like Stu said, it's just a half of an arc second. I mean, half of an arc minute. 30 arc seconds. So that's 2643.
Observation logged.
2637. Here's 2637. Again, just a wisp. $26.47. Sure is a lot easier with deep sky image annotation, huh? UGC 4526.
DSA copied to clipboard.
Right here. That's nice. Edge on. Just looks like a needle galaxy look-alike with a little core. Zwicky 8956. This is so nice that Pete made this for us. Now we can do this. Whoop. Input string was not in correct format. I'm going to capture a picture of this just because this might be something Pete might be able to help us with. Your new EAA Control Panel 0.5 beta 5 works great, Pete. The only error I saw was inline. Okay. Why don't we close this and reopen it just to see if that resets things. Nope, still gets the same thing. And then CG 89 dash.
DSA copied to clipboard.
Down here, Zwicky 8962, CG 8962. Tiny wisp of a galaxy again. Okay, I think those have all been marked as observed. Wonder why some of these, there are objects in M101. I remember we looked at those one night. I think we already did those, but they're not marked off here, so we've got to do them. Look at that. Now we're just looking at this set of knots. They're like knots in M101. This lone binocular double, it's at 17 degrees. Let's go to it right now, just to get it out of the way. HR 6552, it's a double star. HR 6554. I've actually got the sound on from outside. I don't know if you can hear it. See if you can hear it. I'll turn my mic off for a second. Can you hear the sound from the outside? It's supposed to be like just the night sounds, you know, like crickets. Maybe a fan on a telescope or something. Anyway, that's the mic from the security camera that's viewing the telescope. Look at that double. Nice. A beautiful double star. Wow. Just look like a pair of headlights coming from a spaceship from another galaxy. HR 6554.
Observations for 3 objects logged.
Okay, now it looks like we have this set of knots in M101. We have this galaxy cluster. And then this galaxy cluster. This cluster here is below the horizon. Let's just go to M101. I don't know which one of these would be the center. Like that would be as good as any. Let's slew to that. Not many crickets in the winter. M101. Closing in on the end of this list, gang. This has been a very long set of targets. Okay. Look at that. Beautiful. It's a beautiful, beautiful galaxy, right? Looks like a pinwheel. I'm going to hold the shift key down as I move that line. That is like giving you more fine detail. Okay, let's see if we can find some of these now. I wonder if we just that NGC 5450. Yeah, look at those knots. 5447. Those knots. 5449. Up here. 5450. One of those. 5451. That one's not on this list, so we'll grab him. 5451.
DSA copied to clipboard.
Come back here and paste him in. Over here, that knot. Boy, deep sky image annotations is a game changer. 5453. Beautiful. Each of these is a separate kind of nebula. 5461. Beautiful. $54.62. Down here, H2 ionized region. $54.71. See that. Ah, way down there. Kind of greenish tinge. All of these look like knots or wisps of nebula within M101. All right.
Observations for 11 objects logged.
How do we miss these? That one's at -3 now. Ursa Major Dwarf, PAL 4. Ursa Major Dwarf, 14th magnitude, 2 arc minutes wide. Number 161 in the Monster Scope Challenge. A renegade globular cluster within the Great Bear. Palomar 4. It just goes to work out there and just keeps churning away, doesn't it? And the cold and the wind. It's nice, Pete. Love that you can put the the text up there now. It's just so nice. So nice. Power 4 is not there, so we'll add it to
DSA copied to
Sharpcap.
clipboard.
Right there in the middle. There's the globular. Beautiful.
Observation logged.
UGC 6253. I want to thank you guys for riding along with us on this observation night. Get some of our muscle memory back. Try some of these new tools, stuff that Pete's made for us. We haven't gone over to Stellarium much,
Selected.
but he's got that set up for us too. Thank you, Pete. Right here.
Selected.
If we find something in Stellarium, we can add it to AstroPlanner. That just shows our scope location.
Selected.
So this is supposed to be UGC 6253. Galaxy, and it's 15 arc minutes wide. Wow. Leo 2, Leo B, 159. 301. Oh, yeah. A dwarf spheroidal. These are weird.
DSA copied to clipboard.
Right there is where it's going to be. Right there in the center. Pretty big size, but pretty faint. Huh. Okay, while that's collecting some frames, let's kind of recap. We use primarily three pieces of software. The planning application, which is AstroPlanner, that's where we input the list so we know where to point the scope. And then once we've observed something, it's where we mark it as observed so we know we can go on to the next target. So that's our planning software. The second piece of software we use is the Stellarium, which is Planetarium software, and that's so that we can get our bearings with the night sky and sort of see where we are on our, it's like a map, star map. Then the third piece of software we use is the imaging application, Sharpcap, and that's the piece of software that collects the frames from the camera, stacks the frames in the software's RAM, in its volatile, in its volatile memory. It's stacking frames, so it's averaging out the faintest objects, hopefully. Then we have been fortunate enough to have a good friend on the Isle of Wight, off the coast of UK, who's written this control panel software that ties all three pieces of software together makes it a suite so that it can exchange messages with each other. And largely, Pete has used, I think, the language in AstroPlanner to be able to do that. But he's had to interface with the language in Stellarium and the I guess you could call it the API or the sequencing language, whatever, in Sharpcap, that lets you paste in the specific, format or credentials of a particular designation. So it pulls together all three softwares in one big suite. Now in this case, because this particular object is 12th magnitude, you would think that you could see it rather easily, but unfortunately, that 12 magnitude is scattered across an area of the sky that is 10 arc minutes wide. So when you scatter out that much magnitude, over that much space rather, you you have kind of a hard time because because it averages out the magnitude over the entire larger space of the night sky, which means you're rolling down the amount of magnitude you can see in any one particular square inch. It should be right here. And it'll just be a faint glow. There it is. See how it like floats there? Almost like a ghostly glow right there. See that ghostly glow? That is the spheroidal galaxy thing. They're so weird. These spheroidal galaxy deals are so weird. If we stretch the mids up almost to the black levels, the black level bar, the glow sort of wafts in like a giant grainier patch. Well, either way,
observation logged.
Right there. See that glow come in? Right, so we missed this one. IC 2388. I have to go back and pick it up. Ken, thanks for being with us. Thanks for staying up. This is IC 2388.
DSA copied to clipboard.
Kingman, Arizona. Kevin, good to have you aboard. See, are you guys 3 time zones away this time of year? So is it 9:07 p.m. there? It's a beautiful part of the night sky, isn't it? I see 2388 right in the middle. Another little wisp. So tiny. Wonder if there's anybody there looking back at us.
Observation
Okay.
logged.
So we've got one knot here, NGC 604. And then we've got this Able galaxy cluster and then this ARP 154. So just 2 sets of clusters now. Like I say, this one is below the horizon, but we can do this one that's Able 1060.
Selected.
Yeah. I wonder if I forgot to slew. Yes, I did. 10:08 p.m., so just 2 hours apart this time of year. Able. Kingman, Arizona. These are This galaxy cluster is 134. Look at the look at the chart Harrington gives you to find all these. If you had to do this by paper map, some chart, right? Look at all those little galaxies. Excuse me. Kind of looks like the Hubble deep field, doesn't it? The famous photo. Okay, so what's the best way to do this? I guess start out up here. ESO 5018. NGC 3285A. It's not on there. Oh, 3285. There it is. Right at the top. ESO 501. We'll grab that out of
DSA copied to clipboard.
AstroPlanner, paste it in. Very, very faint, but nevertheless visible. ESO 501. IC 2597. Here it is. NGC 3285. Right there. Okay, that's labeled 3285A, and this is just labeled 3285. Huh. 3305. Here. 3307. There. Thirty-three oh eight. 3309. Uh-huh. 3311. 3312. 3314. That's cool. Look at that one. 3315. 3314A, spiral and edge. B, looks like more of a globular. I mean, more of an elliptical. (3314) 3314A, that's beautiful. 3314B, it's more like the elliptical. 3315. Thirty-three, 36. Grab that.
DSA copied to
paste it in.
clipboard.
Thirty-three, 36 is not there. So grab that.
DSA copied to clipboard.
Oops, I'm not showing you. So sorry. I was showing you that book. Eli, good to have you aboard. 33. Let's see, what are we down to here? 33, 36, was it? 33, 36. Yeah, it was not in here. So we're going to grab 33, 36.
DSA copied to clipboard.
Paste it in. Must be off this frame.
Observations for 15 objects logged.
Thirty-three, 36. Screw this one. Not much movement there. There we go. PGC 31212. See it. PGC. Nope, not there.
DSA copied to clipboard.
There it is. Right there it is. Little wispy elliptical galaxy. And PGC 31310, 31310. Not there either.
DSA copied to clipboard. DSA copied to clipboard.
It's a big galaxy cluster, man. This is all Able 1060 or ACO 1060. The rest of these are PGC objects, none of which are noted here. So this is going to be PGC 31310. It's amazing. All these galaxies traveling together as a giant family. One 34. Known as Hydra I. AGC 1060 covers nearly 3 degrees of our southern spring sky and includes more than 100 individual galaxies. Hydra I. Another one of those ellipticals. PGC 31312.
DSA copied to clipboard. DSA copied to clipboard.
Man, these are scattered. It's a big part of the night sky. Got about 10 or 12 more in this galaxy cluster.
DSA copied to clipboard.
There it is. Sharpcap's, they call it Sharp Solve now. It's so fast. Look at that. These little worlds with hundreds of thousands of stars, maybe millions of stars. An entire group of galaxies there. This is PGC
DSA copied to clipboard.
31316. (31 316). We have a pretty big field of view with the RASA. It's like 1.5 degrees by 2.5 degrees, but it's still, we still have to move around the sky quite a bit. Part of it is because we're having to live stack to see these. They're so faint. All of them are between 13 and 15 magnitude. So it's at the outer limits of a definitely a 11-inch scope. Without live stacking, we're not really seeing them. So to be able to for sure see them, we have to live stack them a little bit. Otherwise, look at that field. They just look like tons of little star points. And then occasionally you get a spiral on edge that you see. It's like a little elliptical galaxy. And then PGC 31360.
DSA copied to clipboard.
There it is. Another little elliptical. 31360 and then 31366.
DSA copied to clipboard.
It's out of the frame as well. You'd have to love astronomy to be able to do this, huh? There's the 31366. Another little elliptical galaxy. And then 31433.
DSA copied to clipboard.
Right there. And then 31488.
DSA copied to clipboard. ACO or Able 1060, Hydra. Hail Hydra.
You guys are troopers to stay on here like this. Got 9 of us observing together here. .488, there it is. 31,504.
DSA copied to clipboard.
Right there.
DSA copied to clipboard.
Over there. It's amazing. 31,580.
DSA copied to clipboard.
It's a tiny one. Right there. $31,585.
DSA copied to clipboard.
Off this field of view. G4L4CTIC. G4L4CTIC. Good to have you aboard. Where are you observing from? Mr. G4L4CTIC. Got about a dozen in the stream now.
DSA copied to clipboard. DSA copied to clipboard.
There's 580. What about this 585? Where was it?
DSA copied to clipboard.
That's off the frame as well. 585. Galactic, Indiana. Where is Galactic, Indiana? Is that a town?
DSA copied to clipboard.
Oh, there's 580. Oh, we got to. Right there. Oh, your name. Galactic. You're from Indiana. Got it. Now I copy.
DSA copied to clipboard.
$588. 3 more. 31,638.
DSA copied to clipboard.
Here, that's a little larger. Unique. Look at it, it's kind of, well, like one of those spheroidal things. Weird.
DSA copied to clipboard. $31,794. And the last one, $31,805. DSA copied to clipboard.
All the way up there. Boy, that's a faint one, isn't it? That does look like one of those spheroidal things. Okay. Let's go mark all these. Let's say most were faint spheroid or faint elliptical. Ellipticals. A couple of those weird spheroidal. Tons of galaxies. Tons and tons. How about that? Well, we went overtime tonight. We're at 2 hours and 45 minutes, but we were on a roll and I hated not to just
Observations for 16 objects logged.
stay on the roll with us. So what do we have left here? We have just NGC 3366.
Observation logged.
This needs to be joined with 1060. How do we do that? Can we drag it? Yeah, we can. We have this one that's at minus 11 degrees altitude right now. It's NGC 604. And then we have just ARP 154. Which is another galaxy cluster. It's at minus 34, so we'll have to watch that one. So this is our 26th session on Cosmic Challenge. And now we have just really one galactic cluster and one, what is that? NGC 604, object 67. Emission nebula to go. So we're almost through with this whole list. Thank you for sticking with us tonight. As I've shared, we're on the outskirts of Louisville, Kentucky. Thanks to each of you for making this community work. If you're watching this live or recorded, if you wanted to hit the thumbs up, hit subscribe. You'll be notified whenever we do these. It also helps get the word out to others who are searching. If you click the like. Want to thank the Lord for making all these cool galaxies, and thank Pete for making this control panel for us. We love that, and thank you for being here. So we'll say goodnight. God bless. Have a good evening.